Welcome. This is episode 2, season 1, episode 2 of Algebra 2.
Season 1.
That's right. So we're going to use algebra to solve systems of equations. Now, like I said, you spent some time doing this in Algebra 1. Your textbook in Algebra 1 is the Chapter 6 stuff. We're going to use substitution to solve equations. We're going to use elimination. But I want to start off with an overview of what is substitution. What is elimination and substitution? What are we trying to do? Trying to find a solution to the system of equations. Okay? So the idea, if I flip over and show you, this is a page from your book. Right? The idea is, for example, like these. Use substitution to determine if the ordered pair is an element of the solution. So, look, how could you tell if this point was a solution? Well, you would just plug in a 3 for your x. You have 3 for x here, 3 for x here, 3 for y here, 3 for y here. And you would see if these would be true. Right? If I plug a 3 in here, it's going to be 2 times 3 is 6, minus 3, that's 3. 3 plus 3 is 6, so you would say, yes, this could be a solution. 3, comma 3 is a point, and it makes sense for the equation. All right, so I'm going to show you on the calculator how you can graph to solve. I'm going to show you on the calculator, and I'm going to show you on Desmos. This is a free online graphing calculator. So in Desmos, it's actually quite simple, and there's a free app you can put on your phone. So I don't recommend using this as a first method. But do the work by hand in your homework, but then double check it on Desmos, just make sure you get the right answer. Okay, I think it'll take you an extra maybe 30 seconds. Check in and see if you get the right answer. So let's try this one, for example. That says x plus y plus x equals 5, and then 3x minus 5y equals negative. Someone remember this, because we flipped, so we got x plus y equals 5, and then 3x minus 5y equals negative 1. So I go over to Desmos. And in Desmos, you don't have to type it in as a y equals. In your calculator, you do. So we'd say y plus x equals 5. Is that right? Anyone remember? I go back. 3x minus 5y equals negative 1. 3x minus 5y equals negative 1. All right, and this is it, right here. That's your solution, 3, 2. Okay, this is what you're trying to find when it says solve a system of equations. You're trying to find the point where they intersect. Oops. Okay, this is the point where they intersect, 3, 2, and that is your answer. That's your solution to the system. Graphing is always okay. Three, 2. Did I say 3, 4? No, we'll talk about it later. All right, 3, 2 is your solution to the system. And I wanted to just remind you, when we take, you take a standardized test like an SAT or ACT or the MME or any of those elemental P, whatever it might be, you can use your calculator to find solutions of systems, right? You can use your calculator. And so let me show you also on the graphing calculator. Let's say we had the same one. Now, if we had y plus x equals 5, in order to use your TI-84, you're going to have to move this x over. You have to put in y equals. Okay, so you're going to have to make this y equals 5 and then minus x. And this one, you're going to subtract the 3x, but then you're going to divide by negative 5. So that's a little bit more challenging in the graphing calculator, but it's not to say you can't do it. So if I bring up my graphing calculator, I go to y equals, clear out anything that's in there. And this top equation, again, you got to solve it for y. So we do y equals 5 minus x. Y equals, you hit the y equals button. And then 5 minus x. And then the second one, we're going to subtract the 3x. So it's going to be, I'm going to put this in parentheses, negative 1 minus 3x. And notice the x key is just right here by the alpha. And I have to now divide by negative 5 because there's a negative 5 there, divide by negative 5. And you can do this on your paper by hand. Okay, so we got our two equations, and we need to figure out where they intersect. So there's our graph. We just saw that in Desmos. But to find out where they intersect, you hit second, and then there's a button called calculate, or the trace button. Second, calculate. Intersect is 5. Now we come closer, hit enter 3 times. You scroll closer, hit enter, enter, enter. And your point is 3, 2. Okay, so we just showed you can use Desmos, which is a free online graphing. It's a free app. You can use your calculator as long as you get into y equals this, y equals this. Then we can get our intersection point. We can use our table if they're whole numbers, and you'll get your graph. Is that clear? Again, you're not supposed to do this in the first method. You should use this as a backup. Like I already did it by hand, I want to check my answer. But if I'm taking and doing this on a standardized test, then I might jump and do the calculator first, just to save yourself some time, depending on the problem. All right. So we go back over here. Let's try a couple of these using substitution. So we talked a little bit about graphing. In substitution, here's some steps you can follow if you're someone who likes to take steps to do these problems. Solve for one of the variables in at least one equation. Substitute the resulting expression into the other, and then solve the equation to get the value of the first variable. Once you get the value of the first, say you found x or maybe you found y, then you substitute that value into one of the original equations, and then you're going to write it as a point, an ordered pair. All right, so let's see here. Step one, so we get y equals x plus 1, 4x plus y equals 6. This is a system. We're trying to figure out where they intersect. Where do these two lines intersect? So we found that y equals, it's already given to us as solve for y. So we already got that. That step one is done for us. Now we're going to take this x plus 1 and we're going to plug it into the other. See what y is here. Y equals x plus 1. We're going to substitute. That's why they call it substitution. So we take the y out and we put the x plus 1 in. So it's the exact same equation, right? It's 4x plus y equals 6, but y equals x plus 1. We already discovered that. And now we thanks. And now we put these together, we get 5x plus 1 equals 6, right? Because 4x plus x plus 1. 5x plus 1 equals 6, minus 1. We get 5x equals 5. We divide by 5. X equals 1. Okay, x equals 1 is our x coordinate. So even if we wanted to start writing our ordered pair, we can start it here. We can say, well, we got 1, comma, something else. Now we already got the answer down here, but we can figure it out still. Look, if this is x equals 1, we can take it and put it into any of these equations. We can put it in here, x equals 1 and solve for y, but wouldn't it be simpler to put it in this top one? Because it's already solved for y. So we figure out x equals 1, we plug it back into this equation, and we get, we put the 1 into the equation, y equals 1 plus 1, y equals 2, so we got our answers 1, 2. Now you can check your answer, obviously, by plugging it into, plug these points back into here. Plug it into both equations. Plug into both equations. So checking my answer, it looks like this. I got a point. I think the answer is 1, 2. Okay, we're wondering if this is the correct answer. We plug it in here. 2 is our y. 1 is our x. Is this a true statement?
Yeah.
2 equals 1 plus 1. True. And then we get 4 times, well, we said x was 1. And we said y was 2. And do we get 6? 4 times 1 plus 2? Both are correct. It's got to work for both equations. It can't work for just one. It's got to work for both. Let me try another one over here. Notice step 1 is going to become important in this one because it says solve for one variable in at least one equation. Notice neither one of these, on A, they already give us y equals. They already give it to us. In B, we got to figure out which one we want to solve for. Do you want to solve for x? Do you want to solve for y? Which equation do you want to solve? These are your choices. And this is why it becomes, there's a lot of choice in this. But it also, it will sometimes becomes difficult to teach because there's just so many different methods. Did you see the notes over there? If you want them, they're over there. Is there none left? Somebody grab more than one. Alright, maybe just write it down on paper for now. I'll see if I can pick one. Maybe just grab a sheet of paper for now. Okay. So on this particular one, I'm fine with solving either. Now I noticed that in the second one that I don't have any leading coefficients. I think that's going to make it easier. So I'm going to take this equation here, and I'm going to solve it for x because x is positive. So I take it off to the side and say, well, step 1 is what is I solve for either one. I want to solve for x, so I add y to both sides, and I get x equals 5 plus y. Okay, so step 1 is done. Question? Yeah, now you're gonna take this and plug it into the top equation. Exactly. So we found out what x is. It's 5 plus y. We're gonna plug that into the top equation. And so then we get this. 5 plus y. Instead of writing x, I write 5 plus y plus 2y equals -1. Now we can just solve this and we'll figure out what y is. So long as all your steps, now there's so many different ways to go around on these because there's sign error, you do all the problems right, and then you forgot that negative, and then there's a multiply by 2 when you really did an add 2 and all kinds of stuff. Right? There's a lot of places to make mistakes. That's why this becomes a difficult section. But if you do all your algebra right, this should work out quite nicely. So we solve for x, we plug it back in, then we solve this equation. 5 plus y plus 2y equals -1. These parentheses at this point, because there's no negative out here, we're not multiplying anything, the parentheses can go away. We didn't even need them at this point. I just put it to show that that's x. Okay, 5 plus y equals 2y. So 5 plus y and 2y makes 3y. And I'm going to subtract 5, and I get 3y equals -6. Now I divide by 3, and I get y equals -2. Everyone's on board? If y equals -2, that's one of our points, right? So we're starting to think about our answer here. Our -2 is our y. We just need to find out what x is. So in order to find out what x is, we take this y value. We can plug it back in anywhere. If I were you, I would plug it back in here because we already solved for x. Do you have to plug it in here or here? No. You could actually plug it into the equation you solved. I can take this -2 and plug it back in here. I don't have to plug it in here or here, although I could. I'm sorry, why? I can plug it in here, I can plug it in here. Easiest spot is here. So we say x equals 5 plus y. Well, y is -2. And 5 and -2 make what? Okay, so we got our y coordinate, we got our x coordinate, and you should write it in an ordered pair like so. This is our final answer. You check your answer by plugging them back in here. Okay, if I put a 3 in there and a -2 in there, I get 3 plus 2 times -2 is -4. 3 plus -4 is -1, very good. And then 3 in here plus a -2. 3 minus -2 is 5. What questions do you have on that? Okay, there are 2 problems down below. They say try this. I want you to go ahead and do exactly that. Check it out. So look, -2,1 was the answer to the first one. 3, -10 is the answer to the second. Hopefully you got those. You can see me if you didn't, and we can go over those problems. Okay, on the next side, we have solving by elimination. Hey, everyone has their preference, right? Some people love substitution, and they'll do substitution over all else, no matter what. But there are some problems where elimination makes more sense. Okay. And so by elimination, you're just going to eliminate one of the variables. You'll solve generally a pretty simple equation, and then we'll figure out, the rest of it's the same. Plug in one into the other, and so on. So you got to make sure that one of the variables is going to be eliminated. For example, in this one, if I add these two, this equation and this equation, my -4y and my 4y, they cancel, they go away. And then when we do that, we're left with, you add them together, that's 4x, and that's an 8. And then you got 4x plus 8, we can solve from there, right? So this is our steps, and you guys have seen this before, but we're going to add the equations together. Add these. You get 4x, these will cancel, you get, what's 10 and -2? It makes 8. This is where people go, this is where people have a lot of trouble, and I'm going to be specific, with signs, right? Especially if you're multiplying with negatives and so on like that. But if you can remember, ladies and gentlemen, that if they have different signs, they're working against each other, you're going to get a lower number. If I have a 10 and a -2, those are 2 different signs, and they work against each other. If this was a -10 and a -2, it would work together. They're both the same sign. So I generally think of it like they're opposing. They're opposing signs, or are they on the same side? Anyway, we can solve this, add the equations together, simplify, and solve for x. So divide by 4, x equals 2.
They literally told us the answer, talking about substitute 2 for that.
Yeah, because this is the notes. But you're alright, because we're gonna do a couple where they don't give us the answer. Alright, write one of the original equations, substitute 2 for x. Look, you can choose which one you want. You can choose this top one or you can choose the bottom one. I'm generally gonna choose ones that don't have a coefficient. It's just a little bit easier. So I'm gonna take this equation, I'm gonna plug in, along the way, I'm gonna plug in this x equals 2, and my new equation looks like this. 2 plus 4y equals negative 2. And we can simply subtract 2, so minus 2 from over here. We get 4y equals negative 4. We divide by 4, and we get y equals negative 1. So we got our x equals 2, our y equals negative 1, and then write the solution as an ordered pair. The solution is going to be 2, negative 1. You can plug back in and check your answers. One of my favorite things about algebra tests or any kind of algebra questions, you can almost always check your answers. So if you're sitting here taking a test next week and you're looking at it and you say, oh, I'm not sure if it's right, plug this value into your equation and check your answer.
Oh no, this is out of control. It says 24
This is a
minus
disgrace to
27.
freaking society.
Oh, you gotta look at the assignment sheet. I think it might be Tuesday or Wednesday.
Mr. Earl, you get it all.
Let's go.
Okay, so ladies and gentlemen, I'm going to try a couple with elimination, and you might have to use some multiplication first, right? You hopefully you remember doing this. Yeah, for example, hey Megan,
Look at how freaking close
Shayla?
it was.
Are you carrying me?
we got x plus 2y equals 11, negative 3x plus y equals negative 5, right? If I add these together now, they don't eliminate. If I add this together now, I get x and negative 3x, that would be a negative 2x. So I'm going to write this in red because I don't want you to write it. But if I were to add this, I would get negative 2x, I would get plus 3y, and I would get 6. And that nothing eliminated. This is not helpful. Yeah.
You gotta multiply the top by negative 3. And
That's right.
multiply everything by negative 3.
Exactly. So we can do this by
Or no,
changing this.
My 3. My 3.
You can multiply the top by 3. You can multiply bottom by negative 2 too. Also, couldn't you?
Yeah, to get them to cancel
Because you
out.
can get the y's to cancel or the x's. It's your choice. So I'm going to go with what you said to begin with, which is multiply the top, every single thing by 3. This new equation becomes 3x plus 6y equals what?
33.
33. Please remember to multiply every single thing by that. Whatever you're multiplying by, you got to multiply every single thing. So 3x plus 6y equals 33. This equation has not changed. This is going to be a negative 3x. This is going to be plus y. And this is going to be negative 5. And now we can add these together. And what happens is these x's will cancel.
7, 1.
This is the elimination part. Yes, 3x and negative 3x is gone. You said why? I chose 3 because I noticed that if there was a 3, I was thinking it would be nice if there was a 3 here. And because that's a negative 3x. So that's how I could get them eliminated. You're looking for something to cancel the other. And so when I add these together, let's stick with blue. 0x, these are gone. And then we get 7y equals 28. We divide by 7. Yep, and y equals 4.
Do sometimes
And
you
then
gotta
you plug it in,
multiply them
right?
both.
Yeah, sometimes you can multiply them both.
So like on B you gotta multiply.
Yeah, let's
Wait, let's finish
finish it. Look, we got y equals 4. All right, that's the end of the problem. We move on to the next one. Nope. False. Hopefully someone didn't pause the video right before I said no. Because they'd have been lost forever. Look, you need to plug this y back in somewhere. You can plug it in here, you can plug it in here. I like this x having no leading coefficient, so I'm actually going to use this one. And it looks like this. It says x plus 2 times y, and y is 4, equals 11. Notice I put a parentheses around the y and the x when I plug them back in. I put the parentheses. So this is x plus 8 equals 11. Then what does x have to be? X would have to be 3. So my final answer, the answer you're going to leave on the test is not just randomly placing these, but put them into an ordered pair. In parentheses, this is our answer, 3, 4. How could you check this? Well, I gave you a couple different ways. You can use your graphic calculator, you can use Desmos, you can plug back in here, plug a 3 in here and 4 in here. That'd be 3 plus 2 times 4 is 8, and 3 make 11. 3 goes here, it's negative 9, plus 4 is negative 5. This is correct. All right, let's try B. Yes, question. Well, let me finish this because I got the video going.
Like that. It's not divisible like by anything.
Right, so you got to multiply them both. Know what I mean?
Okay, go ahead, do your.
Yeah, let's go ahead and do the notes.
I'm already done.
All right, look, we got negative 5x plus 2y equals 32, 2x plus 3y equals 10. You need to look at what can I multiply to get them to cancel. They have to eliminate. So when I look at this, sometimes you just swap the numbers. So I can multiply this one by 2 and this one by 5. They'll both equal 10, but opposite signs. I can multiply this one by negative 3, this one by positive 2. They'll have opposite signs. Okay, so you can choose. Depends on which one you want to get rid of, but make sure you multiply every single thing. So I'm going to try to multiply the top by 2, and I'm going to multiply the bottom by 5. And you can multiply them both. So this is going to be negative 10x. It's going to be plus 4y. And then 2 times 32 is 64. And on the bottom, we're changing this one also. 10x multiply 5 times 3y is 15y. And then 5 times 10 is 50. So we can change them both. And now notice that both of the x's have the same number but opposite signs. And they can cancel. So what I do is I add these together. These are going to go away. You might even choose to use purple to cancel. And we're going to have 19y equals 114. If you divide by 19, what do you get? 6?
Oh, wait.
20 times. Yeah, 6, right?
Yeah.
Okay, y equals 6. Now, that is not the end of our problem. We only found y. We got to go back in and plug and find x. Okay,
Can
so we
plug it into the original problem?
yeah, either of these, either one. I mean, technically you could plug it in here too, but that's, the numbers are bigger, so I'd rather you go back to here. In fact, I choose the one with the least amount of negatives most of the time. I'm going to take this and plug it, this y equals 6, we'll plug it back into this one. All right, and it looks like this. 2x plus 3 times 6 equals 10. So 2x plus 18 equals 10. Subtract 18 from both sides, and I get 2x equals negative 8. Divided by 2, we get x equals negative 4. So we got y equals negative 6 and x equals negative 4. So our answer, negative 4. I said negative 6, but I meant positive. Here's your answer, negative 4, 6. This is the point where both of those graphs will intersect. Question?
When you're solving for like one of the functions and you're trying to determine if like the number of solutions it has.
Yeah, we're about to do that.
Oh, perfect.
We're about to do that in the notes. Look, ladies and gentlemen, this one here says check it out. I'd like you to try this. Even if you're working on, maybe working on tonight's assignment, do this one real quick for me. I want to just come around. I'm going to put a little check mark on your paper that you did it correctly, or maybe a sticker. How does a sticker sound?
Oh, sticker please.
Okay, sticker. Example 3, check it out. It should have been 2-0. As I circulated, many of you got that correctly, done correctly, so that is fantastic. All right, our last page for today. There are certain situations where the lines don't ever intersect, or sometimes the lines are exactly the same line. Okay? So the difference between those is sometimes you might have no solution if the lines run parallel, or sometimes you might have infinitely many solutions, meaning that they're the exact same line. Okay? So it says a system that has no solution is called an inconsistent system. Right? The no solution, they're parallel lines. This has one solution. This is infinitely many because both the lines are exactly the same. If both lines are exactly the same line, then you have infinitely many solutions. And let me show you how this looks algebraically. Okay? Systems with no solutions. And it's written up above. See? Systems with no solutions are called inconsistent. Their slopes are equal, but their y-intercepts are different. Okay, so if you get two lines that have the same slope but different y-intercepts, say y equals 2x plus 5, y equals 2x minus 3. They have the same slope, meaning they're parallel lines. Different y-intercepts means that they'll never touch. This is an inconsistent system, and there's no solution. You'd have to say no solution for that. Okay, here's a couple of examples. Notice here, if we use substitution, y equals x minus 4, we can plug that in for this y. So to solve this one, I would say negative x plus y equals 3. Well, that y is this x minus 4.
Man, we got a lot of different problems.
So this is negative x and positive x, those cancel, and we get negative 4 equals 3. Huh? What does that mean, negative 4 equals 3? That's not true. So what do you say, no solution? Exactly. If this were a true statement, we could say infinitely many solutions. But this is not a true statement. Negative 4 does not equal 3. So we'd say no solution. This is an inconsistent system. It's no solution. They're parallel lines. How about this one? Let's see what happens on this one. We can take this. We can use substitution again. Y equals negative 2x plus 5. We plug it in for y. It looks like this. 2x plus y equals 1. 2x plus y equals 1. I'm using this equation. So y equals negative 2x plus 5. So 2x and negative 2x cancel. We get 5 equals 1. Nope. 5 doesn't equal 1. So you just say no solution. And if you were to graph these two lines, you would see that they're parallel and they have different y-intercepts. So you say no solution for those. Okay, will you have some questions on the test that are no solution or infinitely many solutions? Sure. Yeah, absolutely. System with infinitely many solution. Okay. Infinitely many solutions. This is consistent. It's dependent. And the slopes are equal. And the y-intercepts are equal. So in this situation, if I were to use substitution again, I know that y equals 3x plus 2. I can put it in for this y. And so I get this new equation. I get 3x minus 3x plus 2 equals 0. Notice this is very important. This is why I put this in parentheses, because this negative is going to apply to both things. It's going to apply to this, and it's going to apply to this. I forgot to put plus 2, sorry.
What would it be plus 4?
Well, it's going to be plus 2 here equals 0, and then it will be. So look here. We got 3x and we got negative. So this rewritten, it'd be 3x minus 2 plus 2 equals 0. And you know what? Everything cancels. Negative 3x minus 3x is 0. Negative 2 plus 2 is 0. 0 equals 0. This is a true statement. But we don't have an x equals something or a y equals something. We just get a one constant equals the other constant. So we say infinitely many solutions. This is the exact same line. Okay? When this happens, it means that this line and this line are exactly the same.
And then if it's a different number, then it's,
There'd be no solution. Yeah, like if it said 0 equals 5, you say no solution. If it's one solution, you'll still have an x here. And you'll have x equals something.
Oh, okay.
It's only when the x's and the y's drop out completely that you have no solution or infinitely many solutions.
Okay.
Good question. Now look here, I'm going to try to do the same here. I'm going to say, well, if y equals x minus 3, we'll plug in for y. X minus 3, that's our y, minus 3 equals 0. X minus x is 0. Negative 3 minus 3. Oh, this is a negative negative, so that makes x minus x plus 3 minus 3 equals 0. Everything cancels. It doesn't have to be, by the way, it doesn't have to be 0 equals 0. It could be 3 equals 3, 10 equals 10. Anything that's a true statement, we'd say, okay, that's true, but we don't have an x anymore, so that's infinitely many solutions. Because we got a true statement, there's no more x, there's no more y, everything's gone.